Although the state has seen a reduction in fatal and serious injury accidents due to the use of cable barriers, accidents are still likely to occur because no barrier system can completely prevent accidents. If you are an emergency responder to an accident that involves a cable barrier and a vehicle, the first concern is the vehicle occupants. While the accident data reveals that the severity of accident damage to the vehicle's occupants can be reduced compared to other barrier systems, there still could be life-threatening situations. Cable barrier has been adopted for use in medians in almost every state in the country. As the level of experience with cable barrier systems has grown around the country, researchers and product developers continue to refine and improve their safety performance. The goal is to continue to provide effective solutions to improve safety for the millions of people who rely on Washington's highways every day. Cable barrier systems are also a cost-effective strategy to improving highway safety. The cost to install the 177 miles of cable barrier system is comparable to the cost of installing only 98 miles of beam guardrails or 68 miles of concrete barriers. In comparing their performance, accidents involving the cable barrier produced significantly less serious injuries and fatalities than the concrete or W-beam barriers. Cable barrier systems are installed by setting out concrete sleeves to house steel posts. The crews drill holes into the ground and insert concrete sleeves. Once the sleeves are set, the crews slip the steel posts into them and string out the cable. The anchor posts provide the primary mechanism which carries the impact load and sets the tension of the cable. There are two types of cable barriers, low tension and high tension. Transportation officials switched to the high-tension systems in 2005 because they are easier to maintain and the increased tension keeps the cables taut after some of the posts are knocked down, thus continuing their protection until repairs can be made. An easy way to determine if it is low tension is to look for the distinctive spring compensators at the end of the terminal of each cable barrier. The cables in the low-tension barriers are mounted with J-bolts to posts placed 16 feet apart and secured to concrete anchors which are buried. At the anchors, the cables are attached to springs and tightened. The springs are designed to expand and contract with temperature change in order to keep the cables tensioned at approximately 1,500 to 2,000 pounds. The cables will tighten and flex as they bring the vehicle to a stop without redirecting it back into traffic or allowing it to cross the median. In standard vehicle crash tests, at over 60 miles an hour and an impact angle of 25 degrees, the cables flex as much as 12 feet. It can stretch much more if hit by a large vehicle or at a severe angle and speed. The barrier posts are designed to bend over when struck by a vehicle. If a vehicle hits the end of the barrier where the cables are anchored, the cables are designed to release from the anchor, lessening the force of the impact transferred to people inside the vehicle. But this will only occur if the vehicle strikes the post before the cables. Most of the cable barrier systems are of the high-tension type. There are 43 miles of low-tension barrier and 134 miles of high-tension barrier. If you are uncertain as to which type of cable barrier system is involved in an accident, assume it is the high-tension system, as the procedure is the same for the low-tension systems. Much like low-tension systems, the high-tension barriers typically involve 3 strands of steel cable mounted on posts. During the last 7 years, private manufacturing companies have developed high-tension systems that reduce deflection so that the cables don't flex laterally as far as their low-tension predecessors. Therefore, they can be installed in narrower spaces. The high-tension barriers used in Washington State string the cable through slots in the middle of the posts, typically spaced 16 feet apart. The anchors for this type of system have been placed as much as 3 miles apart, although other obstacles such as bridges, other barrier systems, or highway hardware often make that length impractical. Each cable is attached to its own anchor post and is designed to break free when struck by a vehicle. Every 1,000 feet, cables are tightened at turnbuckles, applying more than 5,000 pounds of tension to the cable. When a vehicle strikes the high-tension cable median barrier, the posts are designed to bend down, allowing the cables to slip out of their slots to catch the vehicle. In crash tests, the higher tension cable flexed up to 10 feet, which is 2 feet less than the low-tension system. When you arrive at the scene of an accident, life safety should never be compromised. Patient care is paramount. Access and assess patients first, so that golden hour treatment is not delayed. Notify Washington State Department of Transportation through dispatch, or utilize wsdot crews already on the scene as experts on how to deal with the cable system. Do not cut the cable unless it is necessary to access the vehicle occupants. Once the cable is cut, it is no longer in service to provide a barrier to the traveling public. If the cable is lying on the ground, it could still be fully tensioned. If the cable is lying across the vehicle, you may try lifting the cable off the car, but this may require at least 3 people, as the tension will make the cable seem very heavy. If the cables are tangled around a vehicle, lifting the cables out of the post may be appropriate. However, if you start to raise the cables and the post is lifted, stop and pull the post out of the way. Use extra caution and secure the post with a chain or restraining device, as it may be under significant tension if cables are twisted around a vehicle. If it is necessary to cut the cable, here are the recommended procedures. Cut between 2 undamaged posts where the cables are parallel and not being subjected to multiple forces. Secure the cable with duct tape or equivalent on each side of the cut to prevent unraveling. All persons should be removed from the cut area except the tool operator. The known safety zone is 90 degrees from the cable behind the tool operator. Collisions with the cable barrier may significantly increase the cable tension with deflection. However, our experience has been that when the cable is cut, it drops straight down. An alternative method can be used if a turnbuckle is nearby. Rather than cutting the actual cable, cut at the middle of a turnbuckle. This eliminates the need to tape the cable and facilitates easier repair of the barrier after the incident. Life safety should never be compromised. Patient care is paramount. Access and assess patients first, so that golden hour treatment is not delayed. Do not cut the cable unless it is necessary to access the vehicle occupants. Once the cable is cut, it is no longer in service to provide a barrier to the traveling public.